Hey, Walter Sorrells back with more tips for the knife maker. Today, just because it's scrap doesn't mean it's crap. So most of the knife makers that I know keep a lot of scrap around their shops. Anytime you do a project, there are always going to be little bits and pieces that are left over. It seems like, hey, if I hold on to this, eventually I'll find a use for it. Well, in my case, I know that I really do find a use for a lot of those things. So today's knife is going to be a case in point. Almost all the material that I'm going to be using today was cast off from some other project. It was just excess material, but I keep it all on hand, and eventually there's always a use for it. All right, let's jump in and we'll see what I'm talking about. I'm starting with a piece of 0.155 inch by 1.25 inch S30V stainless steel. I make a fair number of blades from this size stock for my Tactics Armory line of knives, and often there's some leftover stock. This piece is plenty big for a knife, so I've worked backwards here. Instead of coming up with a design and then finding stock to fit it, I'm sketching out the blade specifically to fit the piece of steel that I have in hand. I'll pick up some measurements for the pins in the thong hole and the Spanish notch, and then I'll drill and mill them on my mill. Whether you have a mill with a digital readout like this, or you're just using a benchtop drill press, or even a hand drill, you're always better off drilling the holes before you profile the blade. Easier to clamp, easier to support, easier to make sure it's square, easier to measure, and on a mill with a digital readout like this, it's way easier to indicate the edges so that you can drill the holes accurately. I've got other videos where I show how to drill these holes with much less complex machinery, but the general principle of starting with the holes first is true in all cases. While I'm at it, I can grab some micarta from the scrap pile and make some handle scales. The beauty of doing it on a mill is that while you have everything set up, you can drill the exact same hole locations using the DRO without changing your setup. If you don't have fancy equipment though, you can just clamp the scales onto the stock, drill through the holes in the steel, and everything will line up perfectly. Like I said, I've got plenty of videos where I've showed this process. I'll attach a link in the description and the cards to one of my videos where I make a knife using much more simple tools. By the way, if you want to replicate the dimensions of this particular knife, I'll have plans available to my Patreon subscribers on my Patreon page. Links in the card and description. I'm using small pins to hold the handle on, known as corby fasteners. These require a step drill to make a counterbore for the heads of the fasteners. Anyway, you can just guesstimate the depth of the counterbore, or you can do the tedious math thing like I do here and calculate the counterbore depth to fit the shank of the corby pin exactly. It's okay for your counterbore to be a little too shallow, as that'll give you some meat for the corbies to snug down on. If you go too deep, however, the corbies won't be able to press the handle scales together, and you'll lose the whole value of using them, which is that they form a mechanical lock to keep the scales nice and tight to the tang. Here I'm milling out the Spanish notch. If you have a big enough piece of stock, what you can do is drill that and then grind through half of it, and you'll be left with a nice Spanish notch. In this case, I've got smallish stock, so I'm just milling into it. I have lots of used, bunged up old end mills. I keep them around, and in an emergency I can always pull them out and use them. Now, of course, I've got plenty of good ones right now, but I'm just showing that it is possible to use a really toasted, worthless looking end mill to accomplish something in a pinch. I don't really recommend doing this, and of course you want to wear eyewear because it's pretty easy for them to crack and throw little bits of shrapnel around. But in this case, the end mill does a perfectly fine job. Hey guys, just a quick shout out to our sponsor, Combat Abrasives. I use Combat Abrasives belts on my grinder every day. Their ceramic belts in particular are cost-effective workhorses in my shop with one of the best price points in the industry. Combat is a family-owned American company with manufacturing facilities right here in the US of A. They've also just released a new 2-part epoxy, Rogue Epoxy, that has 1,000 uses for the knife maker. See it used in today's project in just a few minutes. Find them at combatabrasives.com. Alright, back to work. Now I'll profile the blade on my grinder. I start roughing everything on the table with a flat platen, then move to some contact wheels for other parts of the profile. Once I'm happy with my profile, I'm ready to grind the bevels. First, I'll use a scribe to mark the center lines of the bevels. It's really important to keep them even, so having a reference line just makes the whole process a lot easier and more foolproof. I start with a 40 grit ceramic belt, then move to progressively finer belts to refine the lines. Now it's time to heat treat the blade. S30V is a vanadium stainless steel. If you were watching the video I did a couple weeks ago where I forged a high carbon steel blade, then heated it up in my forge and quenched it in oil, well, that's not an option here. All stainless steels are much more finicky about how they need to be heat treated. In this case, I'm wrapping the steel in a special heat treating foil to keep it from coming into contact with oxygen. Then heating the steel to 1900 degrees, soaking it for 30 minutes, then plate quenching it by smashing it between two heavy aluminum plates. The plates both suck heat out of the steel and keep it flat so that it won't warp. This causes the steel to harden substantially. The original stock would have weighed in at about 30 Rockwell, whereas now it's about 63 HRC, too hard and too brittle for practical use. So, once it cools down, I do 2 cycles of tempering at 400 Fahrenheit. Now, if you want to make your own knife out of a stainless steel like 440C or something similar, you don't need equipment like this. You can send it off to any number of heat treaters to harden and temper the steel, including most of the major knife-making supply houses that you'll find online. After heat treat, I'll clean off the scale that's formed during heat treating. Then a few passes on the grinder for the same purpose. Everything's nice and clean, so we're ready for the handle. I'll begin with some preliminary work on the handle scales. First, I'll scribe the front of the handle scale, shaping it on my disc grinder, then hand sanding the front face of the scale. By holding the assembly together with the corby pins, I assure myself that the scales will be perfectly symmetrical. In the final assembly, I'll also use a thong hole tube made from 1/4-inch stainless steel tubing. I'm going to be epoxying the handles using Rogue epoxy, kindly provided by our sponsor, Combat Abrasives. A couple important things with epoxy. First, anytime you epoxy anything, especially non-porous surfaces like steel, you want to be exceptionally careful to clean all oils, fingerprints, and gunk off of it. In this case, I'm using acetone. You can just wash it in the kitchen sink with dishwashing liquid though. Just make sure you don't handle it at all once the cleaning is finished. I'll also rough up the inner surfaces of the handle scales, giving the epoxy more surface area to hang on to. This also flattens any burrs on the drill holes, which can cause problems in flattening the scale to the tang. Especially when using a quick setting epoxy like this, it's crucial to get everything set up before assembling the handle. You want your epoxy, towels, solvent, pin, thong tubes, a couple of screwdrivers, a hammer, whatever it is that you might need. I personally have never launched into handle assembly and realized I've forgotten some crucial tool while the epoxy is setting, but I hear it can happen, and that it sucks. Anyway, the epoxy's mixed 1:1. Then I'll assemble everything using a fairly thin application of epoxy on the scales in order to minimize messy squeeze out. Then the pins go in and get tightened with 2 screwdrivers, a fairly awkward process. Unless you way underestimated the depth of the counterbore, you'll need to torque them down about as far as they'll go. Then I'll tap in the thong tube with a hammer. Next, I'll juggle clamping and cleaning squeeze out. You don't want a big ugly bead of epoxy forming in front of the handle scale. Because I didn't go hog wild with my epoxy, the squeeze out isn't too bad. I've tried any number of things for cleaning squeeze out, and my favorite solvent is just good old rubbing alcohol. More aggressive solvents like lacquer thinner and acetone seem to wick into the crack and leach out more epoxy, weakening the epoxy bond. I've heard baby wipes are good too, though I haven't tried them myself. Once the epoxy is cured, it's back to the grinder to shape the handle. First, you'll need to grind off the heads of the pins. When grinding off the pins, you don't want to be too aggressive. Overheating them will cause the epoxy to burn, weakening the epoxy and sometimes discoloring the handle material. Thanks for watching, guys. If you feel like you got something out of this video, don't forget to subscribe. Also, click on the link to Patreon for a great way to give back to the channel. Plus, check me out on Instagram, Facebook, Twitter. Links in the description. If you want something sharp and pointy, maybe a gift for yourself or one of the cooler people in your life, check out my Tactics Armory website and pick up one of our tactical or outdoor knives. And finally, if you want to learn to make Hamones or Japanese swords, check out WalterSorrellsBlades.com, where you can find videos about how I make Hamones, as well as forging, mounting, polishing, and fittings for Japanese swords. Thanks, and see you soon.